Welcome everyone, we would like to present our homework called RAM metering control on freeway. The task was to create a simulation framework with the help of SUMO. We used the freeway stretch to simulate the traffic flow and place the traffic light, and some loops as well for measuring the values. We had to choose an algorithm to control RAM metering, and we will present some figures at the end. We worked in SUMO. SUMO is an open source traffic simulation package. With this we could easily implement the traffic light and loop detectors. We can define different types of vehicles in the environment and adjust the traffic flow. With the traffic control interface we can intervene online in the simulation and retrieve the values. The choose highway stretch is at the intersection of the M1 highway and the 102 main road near Hertekon. On the pictures you can see the stretch from the Google and the created environment in SUMO. We defined two types of vehicles. The first type is truck vehicle with a 0.5 meter per second square acceleration, a 4.5 meter per second square deceleration. The length of the vehicle is 15 meters. The maximum speed was set to 90 km per hour. The vehicle flow for this type was set to 1000 vehicles per hour in the mainstream flow and 200 vehicles per hour in the RAM flow. These informations can be found in the track trips XML file. The other type of vehicle is the passenger vehicle. For this we set a 1 meter per second square acceleration, a 4.5 meter per second square deceleration. The length is 5 meters and the maximum speed is 130 km per hour. Here we also define two flow types, 5000 vehicles per hour for the main flow and 1000 vehicles per hour for the RAM flow. These also can be found in the passenger trips XML file.
Our map has altogether 3 induction loops. Only 2 of them was used in the ALINEA algorithm. Those are the loops measuring the output occupancy, which is the output traffic of the main lines, and the RAM together. The RAM detector is only used for preliminary measurements for the RAM metering algorithm. Also, we have a traffic light. We use this with fixed green and yellow durations. The traffic flow controlling was with the red durations. The fixed green duration is necessary to break up patterns because with this only 3 vehicles can get through the RAM. ALINEA is a recursive RAM metering algorithm. We used it for calculate an optimal RAM flow. The output of the algorithm is the RAM flow, and the only input is the current output occupancy. It has 2 constant parameters, the desired occupancy and the regulator parameter. The ALINEA algorithm returns a flow value. To set this flow, we have to measure the throughput, calculate the current flow, and adjust the duration of the traffic light phases. This would be another controller beside with ALINEA. This new controller can be eliminated with measurements because the mainline flow actually has no effect on the RAM flow. These measurement results can be seen on the diagram. So it is easy now to set the flow with the traffic light by choosing the closest RAM flow from the list and set the corresponding red light duration.
On the figures we illustrated the measured values of the simulation. The 3 axes represent the output occupancy in percentage, the red light duration and the time of simulation. On the first image we can see the output occupancy mainly moved in the 10 and 16 interval, and the desired occupancy is equal to the mean of this interval. Lower occupancies occurred at lower duration, like at time 3200 seconds. The duration was 70 seconds with only 8% of output occupancy. On the second image the output occupancy mainly moved in the 12-16 interval with a mean of 14, and we can see the control in most cases exceeded the desired value. The red light duration has been grown and was mainly in the interval of 100 and 120 seconds. On the third figure, the output occupancy wasn't that effective. It was in the 10-15 interval with a mean of 12.5, so mainly under the desired occupancy. The algorithm decreased the red light duration until 900 seconds, and the output occupancy has stuck at 3 seconds after that. For future development, the sensitivity of the algorithm with some weights could be modified. Thank you for the attention.